All right, so energy. This whole unit deals with energy. We're going to get into a bunch of processes of how organisms create energy, but we really got to know what energy is and what the energy molecules are that we use in order to get into that. So energy, remember, is the ability to do work. So if I have energy, I can do work. If a cell has energy, it can do work. If it doesn't have energy, obviously can't do any work. So there are two types of organisms that obtain energy in different ways. First of all, we have a heterotroph. Heterotroph gets energy by eating or consuming its food particles, okay? I'm just going to abbreviate consuming, right? It has to take in energy. And then once it takes in that energy, it can create its own energy. Another name for a heterotroph is a consumer, okay? So what do we have that's a consumer? Well, we are animals, fungi. A fungus, like a mushroom, is actually a consumer. We can name any animal in the animal kingdom. It's going to be a consumer, all right? It has to take in its energy. It has to eat. It has to consume its food in order to get energy. An autotroph is, another name for it is a producer. Why is it a producer? Well, it's a producer because it produces its own energy. It produces its own food. Excuse me. Now, how does it do this? Well, there's a couple different ways, but what we're going to find out is that mainly producers use photosynthesis in order to produce their own food. So that's an autotroph. Well, what are we thinking of here? Plants. There are types of bacteria that might be photosynthetic. Some protists are photosynthetic, all right? So they make their own food. Now, here's the really important part. All heterotrophs and consumers rely on autotrophs. Basically, the whole world is driven by and is given energy by autotrophs. Okay, if you think about it, grass grows using the sun's energy, and then a cow eats the grass. Well, how is a cow living? Because it eats the grass. And then maybe we have tacos, which was beef. Well, if we eat that beef taco, the only reason we're able to eat a beef taco is because we are eating the cow that ate the grass. So everything relies on producers, all right? Now, as far as types of energy, and I'm going to abbreviate here, we have talked about kinetic energy, so I'm just going to go KE, and potential energy. So let's start with kinetic energy. Kinetic energy is energy in motion, okay, or movement. So something that is moving or in motion is kinetic energy. There's a ton of different examples of kinetic energy. For us right now, in this class, we're going to focus on thermal energy. Thermal energy is heat energy. Now, why is this considered kinetic energy? Well, the more or the faster that particles are moving, the more thermal energy it has. The best example I like to think of is a pot of boiling water. If you watch that pot of boiling water, you see the water molecules start to go faster and faster and faster and faster because they're gaining more and more thermal energy because the heat put onto them, okay? Other type of energy is potential energy. This is stored energy, okay, or energy not in motion. Okay, it could be due to position. It could be due to being stretched, like in class, a couple people gave example of somebody stretching a rubber band. Okay, for our class right now, for this unit, we're going to focus on chemical energy. Now, that says energy stored, and I'm going to put a capital E, energy stored in the bonds of molecules. Stored in the bonds, okay? So if I have a piece of fruit, or I have a piece of coal, I have a can of gasoline, the only way for me to release that stored energy, that chemical energy, is to break the bonds of that molecule, and then the energy is going to be released, all right? So remember that energy cannot be created or destroyed. It can only change forms. So if I'm thinking of a roller coaster, I'm at the top of a hill, right? And there's this car up here. I'll draw a really bad car. There's a wheel here. There's a wheel here. Here's a guy about to go down, okay? At the top of this hill, he has a high amount of potential energy, but his kinetic energy is really low. Okay, now as he starts to move down the hill, okay, once he gets to this point at the very bottom of the hill, well, now that energy has changed or transferred into a different type of energy. So now the potential energy has gone way down, and the kinetic energy has gone way up. All right? Because he has transferred his energy from this stored energy at the top of the hill to moving energy as he's going down. Now, if we're talking about like measuring this energy, we'd go back to physical science, which we don't need to do that right now. Okay, but there's a change of energy. Now, how does this work for us? What's this have to do with biology? Well, talked about in class. If I have an apple, that's my best apple, sorry. Okay, this apple has a bunch of chemical energy inside of it. Okay, now because it has chemical energy inside of it, it has energy in the bonds. How am I going to get that energy out of it? Well, I'm going to digest it to release its energy. So I'll just write digest here. And then I'm going to use the energy from that apple to go through a process called cellular respiration. Now that cellular respiration is then, and I know this might look confusing, but then that cellular respiration is going to turn the energy from that apple into an energy molecule called ATP. That ATP is our main energy source. So important, okay? Another example of how I can release chemical energy of something. If I have a piece of coal, okay, that's my bad piece of coal. Let's color it black because coal's most of the time black. Coal has a bunch of chemical energy. What am I going to do to release that energy? Well, I strike a match to it, I light it on fire, and then all of a sudden, that's a flame. It's burning, right? I've turned the chemical energy in the coal, and I've converted it into thermal energy as it's releasing heat because I broke the bonds. So in order to release the chemical energy, you have to break the bonds of that molecule. Okay? So that is just a little video on energy and the different types and the different organisms and how they produce it.